Hello, today we continue solving problems about solutions, and today we will talk about concentration expressed in mass fractions. This is the so-called percentage concentration. To solve problems on the percentage concentration, you need to understand that this is a ratio. The value is the ratio of the mass of the dissolved substance in relation to the mass of the solution. So in the first problem, we're given a mass of sodium chloride, and the mass of water is given. As we understand, water is a solvent, and therefore to calculate the mass fraction, we do not know the mass of the solution, but we need to calculate its concentration. I will only remind you that the mass fraction is sometimes denoted by the letter omega and is expressed in percentages most often, although it can be without percentages. But today we're going to solve exactly in percentages. Since we are not given the mass of the solution, we need to find it. The mass of the solution to find it, we need to add up the mass of the dissolved substance and respectively the mass of the solvent. As we understand in this case, the mass of the solution will be 200 grams. Now to calculate the concentration, expressed as a percentage in mass fractions, we need to divide the mass of the dissolved substance respectively and relate it to the mass of the solution and express this as a percentage. What remains is to do the math manipulation. Here we will have 2, then we divide. Here we will have 20, and the answer therefore will be equal to 20%. So the given substance in the solution is 20% and 80%. It is not difficult to calculate. It will be water. The second problem, to calculate the mass fraction here, I slightly complicated the problem. The amount of potassium hydroxide is given, and the volume of water is also given in this case. To calculate, we need to convert the number of moles of potassium hydroxide from moles to mass. So, first let's show what the molar mass of potassium hydroxide is equal to. We calculate it with reference to the periodic table. 39, 16, and 1 will be 56, respectively, grams to moles. Now, the volume of water, mind you, we have given you 400 centimeters cubed, but we need to convert that to mass. We'll use the fact that we know the density of water, and it's equal to 1, so it's 400 centimeters cubed multiplied by the density of water, which is equal to 1 grams divided by 1 centimeter cubed. Therefore, the mass of the water will be 400 grams. Now we need to find the mass of our dissolved substance, potassium hydroxide. To do this, the molar mass we found is 56 grams to moles. We multiply it by the number of moles of the substance, which is 2 moles. In this case, we have a mole-mole reduction. It will be 112 grams. Now we will find the mass of the solution. The mass of the solution will be the mass of water, and therefore the mass of the dissolved substance, and therefore our solution will be equal to 512 grams. Now to find the concentration expressed in percent will not be difficult. It turns out that we find it in relation to mass fraction, and it will be respectively the mass of the dissolved substance, 112 grams, attributed to 512 grams of our solution and expressed as a percentage. So accordingly, this value will be equal to 21.88 hundredths. 88 hundredths. So the answer to the problem will be like this. So, to solve problems on the mass fraction, you need to understand how the solution is built, what parts it consists of, how the dissolved substance is located, how the unit of measurement for the solvent is translated, for example using density, and also accordingly to carry out the correct mathematical manipulations. But I hope that was clear. Goodbye.